Okay, let's see what we got here. Today we want to work on finding exact areas under the curve. Under what conditions can we already do this? Well, if it's a nice thing. So if we have some sort of function, I'll make it super boring. Just do a line, boop, and we want to find this area under the curve, just use geometry. If we have a line but it starts a little higher, like this, and we want to find that area, just use geometry. If we have, oh, we're going to get crazy spicy here, you ready? If we have something like this, that's a semicircle, just use geometry. Do you get the point? So if you can use geometry, then you can find the exact area under the curve. How can we use Riemann sums to help us out? Well, we should have talked about the more rectangles, the more subdivisions we have, the closer our approximation will be to the exact answer. So the more we get, the more rectangles we have, the better our estimate is. And if we have an infinite number of rectangles, oh, look, the limit as n goes to infinity. So I like this one because there's a whole bunch of stuff going on here. So let me read it and break it apart for you as you kind of cry a little bit because there's a lot going on. So let f be a function defined in an interval. The definite integral from a to b is defined by, so this over here is going to be some of the new notation we're going to use. Definite integral from a to b. The stuff on the right is the Riemann sum idea. So let's read it. Limit as n goes to infinity of the sum from 1 to n, f of x star k, delta x. If this limit exists, where delta x, so delta x is b minus a over n, x sub k is a plus k delta x star is any choice of point in this little subinterval. Okay, that's a lot. Let's break that down. So n is how many rectangles? N is the number of rectangles. Notice that we're going for an infinite number of rectangles. We'll go in order here. So the delta x, they tell us is b minus a over n, is the width divided by number of rectangles. And like that's the total width divided by the number of rectangles. So that's kind of like the average width of each rectangle, that sort of thing. The x sub k, it says it's a plus k delta x. So it's a, where we start, plus however many rectangles times how wide it is. So that tells us where we are. And if I think about that graphically, maybe that'll make more sense. If I have my a value here, and then I have x1, x2, x3, my xk, so my x1, equals a plus 1 delta x, because right in here is a delta x. So it's a plus delta x. x2 is a plus 2 delta x's. So 2 delta x's gets us to x2. And then x star k is any choice of point in the interval. So if we have some sort of curvy curve in here, x star k would be any choice in here. Obviously, to make things easier, with that previous page, we'll make the intervals the same size and all that stuff. Now, these are some properties. These properties should be familiar. What is the connection between a to b and b to a? Well, if I go one direction, a to b, f of x dx, that's going to be the exact same as b to a, except backwards. So it'll be the opposite. What do you think is the value of a to a? Well, if I don't go anywhere, I don't get anything, so 0. What's another way to calculate? So the integral from a to b, f of x plus g of x, could also be minus, dx, that's just going to be the integral from a to b of f of x dx plus the integral from a to b of g of x dx You should be thinking of limits properties here, and derivative properties, and summation properties, because they're all the same. Another way to calculate a to c is to do a to b, and then b to c. So a to b, f of x dx, plus b to c, f of x dx. All right, so those are some basic properties. Let's keep rolling. Use some of those properties. So you should try these right now. Feel free to pause and give these a shot, and I will write them down. So if we know 1 to 4 is 2, then 4 to 1 is, negative 2, then 4 to 1 is positive 2. If we know negative 1 to 1 and then 1 to 4, we can just combine those, so we get 3. If we know negative 1 to 1 of f is 5, so that'll be 10 because it's 2 times 5. And if we know negative 1 to 1 of h is 7, we can do 3 of those, so 31. If we know 0 to 1, we know negative 1 to 1, we know 1 to 4. I can't figure out 0 to 1, so we don't know. Negative 2 to 2, we also don't know. And then negative 1 to 4, we don't know because we can't do this part. We can do this part, but we can't do that part.